Hi and welcome back to Quay Does Leetcode. Today I'm going to be doing problem number 153, find minimum in a rotated sorted array. So for this problem, you're given an array and the array is sorted in ascending order, and then it is rotated between 1 and n times. So what rotated in this case means is, say we're given an array 1, 2, 3, 4, 5. For this array, if you rotate it one time, you would move all the elements, shift one position to the right, and then the last element would become the first element. So the last element would become the first element, that'd be 5, and then every other element would be shifted one position. So this is a array rotated one time. If you rotate it two times, you would take that last element and you would move it to the first, and you'd move all the elements one position to the right. So this would be 4, and then the next thing would be 5, 1, 2, 3. This is rotated 2 times. And then finally, rotated 3 times, you would move this last element, you would move it to the first position, and then you would move all the other elements one to the right. So 3 would go first, and then all the other elements would go one to the right. 1, 2. And this is rotated 3 times. And it could also be rotated the length of n times. And if it was rotated the length of n times, then it would end up just being the same array. So if you take you would take this first element and you would make it the first element, and then you'd put all the other elements after it. So if you rotate it n times, it's effectively not rotating it at all. So given an array that is rotated between 1 and n times, you need to return the minimum element. So in this array, 3, 4, 5, 1, 2, the minimum element is 1. And basically, it's the smallest element in the array. Now, how can we find the minimum element? Well, we know that if it was sorted, so one case is if it's not rotated at all and it's just sorted in ascending order, the minimum element is the first element. But if it's rotated, then the minimum element isn't the first element. So how could you find the minimum element? Well, you could loop through the array, and you could look at this and see if that's the minimum so far. Then look at this, is that the minimum so far? Then look at this, is that the minimum so far? You can get the minimum that way, but that algorithm is going to be O of n time, because you have to loop through every single element in the array. And we are specifically told we must write an algorithm that runs in O of log n time. So O of log n is faster than O of n time. So O of n time is too slow. So we know of one algorithm that can do things in O of log n time, which is binary search. So even though this array is not sorted, because for binary search you need a sorted array, is there a way that we can use binary search to find the find the minimum in O of n time? O of log n time. So to find that out, we need to look at certain properties of the rotated array. So let's take a closer look at the rotated array. So all of these are examples of rotated arrays. And where is the minimum in this case? Well, the minimum is going to be 1, and here, 1 here, and 1 here. But notice how we always find the minimum after the immediate element to the right after the highest element. 5, 5, and 5. And 5 happens to be the element, its special element in a rotated array, because it's the pivot element. It is the element where if you cut the array in half and then you switch the order of the two halves, you would go back to being a sorted array. So this is the pivot. Similarly, 5 is the pivot here. Pivot. If you cut this array in half and you switch the orders of the two halves, it would go back to being a sorted array. The pivot. So all we need to do is find the pivot in log n time and then look at the element immediately to the right, and that element is the minimum. So how can we find the pivot in O of log n time in a binary search way? Well, let's see an example. So in binary search, we have 3 pointers. We have our left pointer, our right pointer, and our middle pointer. Our left pointer starts at the beginning of the array, our right pointer starts at the end of the array, and our middle pointer is in the middle, the midpoint between those two. So when we do binary search, we're always looking at our mid pointer and making a decision as to where to look, right or left, for our target. In this case, our target is the pivot. And so this is our midpoint is 1. And so there are 2 situations. So when our midpoint, our midpoint cuts our array in 2 halves. One half of the array is the half that is strictly increasing and it's sorted. So this is the half of our array that is strictly increasing. And if our midpoint is a specific number, and we know that our one side of our array is going to be strictly increasing, and then there's another side of our array that is not strictly increasing. And you see this part array goes 4, 5, 1. And so that's not sorted. So we know that our our pivot is found when we go from a high number from a high number to a low. So our pivot is if we're at a pivot, it would be when say our midpoint was at the pivot, it would be when our midpoint is greater than the number that is right after that number. Because in all cases, when we're not at our pivot, it is the number that is next our midpoint is going to be less than our number that is the next number after it. So for this, for the midpoint of 1, we know it's not a pivot because 1 is less than 2. And then if we were at 2, then 2 is less than 3, and so on. Similarly, if we were at 4, 4 is less than 5, but if we're at 5, 5 is greater than 1. So that's how we know if we found our pivot. So we know if we found our pivot if our mid is, we've found the pivot if our mid is greater than mid plus 1. But how do we know if we're not on our pivot which direction to look for our pivot? Do we look to the right or to the left? Well, if our left side of the graph, our left side of our array is the sorted half, then we know that our pivot is going to be the other half. So in this case, our right side is the side that is sorted increasing. So if right side is sorted, then we want to look left. Then, because this side, you're never going to find the number that gets that goes high and then low from if all of your numbers are going to be increasing. So you don't want to look here. You want to look back here, because this goes 4, 5, 1. So you look left. That means you move your right pointer to mid minus 1. But if our right side, if our left side is the side that is sorted, so in a different example, in this example, our left side is the side that is sorted, and our right side is the side that is not sorted. It goes 4, 5, 1. So if our left side is sorted, then we want to look to the right for our pivot. So if we look to the right, look right, we need to move our left pointer. So our left pointer is going to be mid plus 1. So we're going to move our left pointer here. And that is basically how you find the answer. So let's go through one example fully. So in this example, our left pointer starts at index 0, our right pointer starts at the length minus 1, and our mid pointer starts in the middle. And our mid pointer is 1. Now, is our left side of our to the left sorted or to the right sorted? Well, we know our left side is the side that it's sorted if our left is less than or equal to our mid. And 4 is not less than or equal to 1. So it's the right side that is sorted. So right side is sorted. So if the right side is the side that is sorted, then we want to look to the left. So we move our right pointer. So we move our right pointer to be mid minus 1. So now our right pointer is at 5 and our mid is at 4. So now we want to see, is our left side, so now we basically have we're basically at 4, 5. Left, middle, right. Now, is our left side sorted or is it our right side that's sorted? Well, our left is greater than or equal to our mid. So our left side is the side that is sorted. So if our left side is sorted, then we want to look to the right. So we move our left pointer. So we make our left pointer mid plus 1. So we move our left pointer to mid plus 1. And now our left, right, and mid is at 5. And now we look and we see 4, 5, 1, 2, 3. So now we check and see, is this our pivot? And we know if it's our pivot if our mid is greater than our mid plus 1. So 5 is greater than 1. So we found our pivot. And that's the answer. So we found 5. And so now we just want to return mid plus 1, which is 1. And 1 is the minimum of this array. And that's how we find the answer. So let's see it coded up. So the first thing that we need is we need a left pointer, which starts at 0. And then we need a right pointer, which starts at length of nums minus 1. And then we actually need to handle some edge cases here. So the first edge case is if our array is not rotated at all. Because remember, if the array is not rotated, the minimum is the first element. Now, how can you tell if it's not rotated? Well, if it's not rotated, then our nums at L is going to be less than our nums at right. Because it's going to be strictly increasing. So if that is the case, then we're going to return just the first element, which is nums at 0. Another edge case is if there is only one element. Because remember, the way that we're finding if it's a pivot or not is if the element right to the right, next to the element on the right, is less than the element that we're looking at. But if there's no element to the right because there's only one element in the array, then we can't do that check. So if the length of nums is equal to 1, then if there's only one thing in the element, only one element in the array, then it must be the minimum. So we want to return, we want to return nums 0. And so those are our two edge cases. Now let's do our binary search. So while our left is less than or equal to our right, we want to do our binary search. And then we want to get our mid, which is going to be our left plus our right minus left divided by 2. Now, this is just a formula for getting the midpoint of an array. You could also use left plus right divided by 2, but if you do it this way, you prevent overflow if the integers are really large. So we're going to do left plus right minus left divided by 2 to get our midpoint. Now we want to check if the left part is the sorted part. And you can determine if the left part is the sorted part if the nums at left is less than or equal to our mid, our nums at mid, then it's the left part that's sorted. And if the left part is the part that's sorted, then we want to look right. So we move our left pointer. Left equals mid plus 1. If else, that means the right part is sorted. And so we know that we can't find our pivot to the right. So we move our, we go left. To go left, we move our right pointer equal to mid minus 1. And now what I forgot to do is check if we are, if we found the pivot. If we found the pivot, then our nums at mid is going to be greater than our nums at mid plus 1. If that is the case, then we found our pivot and we just want to return our mid plus, well, we want to return our nums at mid plus 1 because that's going to be our minimum. The next element immediately to the right of our pivot is our minimum. So that's if we found our pivot. Now we have, if our left part is sorted, we want to move to the right. If our right part is sorted, we want to move to the left. And we are guaranteed to find a pivot because we know there's going to be a pivot because we already checked if it's not rotated, we're returning the first thing. So we don't have to have another return statement out here. And this is all the code. So let's run it and see what happens. Okay, so we're getting the right answer. Let's submit it. And it was accepted. So that is how you find the minimum in a rotated sorted array. And thanks for watching, and I'll see you in the next video.